Hello my dear students, welcome to our first video, and today I'm going to talk about rational numbers. What are the rational numbers? Well, that's what we're going to do in this video. So let's start with that. What is a rational number? Basically, a rational number is a fraction, we could say, where you have a numerator and a denominator. Both numbers are natural or integer numbers. That means you won't see, or rarely you will see, a number with a point in the numerator or the denominator. Both are integers, or both are not decimals. So we have two kinds of fractions. We have proper fractions and improper fractions. So let's have a look at them. Let's see where they can lead us. Proper fractions are those where the numerator is less than the denominator. For instance, here I have 3/4. And what does this fraction represent? Well, let's suppose that you have a square divided in 4 parts, and you colored 3 of them. That is 3/4 of those squares are colored. And we can also represent that on a number line. If we start from 0 and start counting 1/4, 2/4 until we get to 3/4, and there we can find that number on the number line. But also let's remember that every fraction represents a division, and if you divide 3 by 4, let's remember that you had to place a 0 here and a 0 there in order to make this division. If you divide 3 by 4, that will give you 0.75. What does this number mean? Well, actually 0.75 is this number. Right here it's a 0.75. So 3/4 is equal to 0.75. And well, this is a finite decimal number. There are no more numbers after the 5. But there are also some rational numbers, like 2/3. If we represent it on a number line, starting from the 0 and then with 1/3 and getting to 2/3, we will stop here. But if we remember that every fraction is also a division, and then we divide, we will get the number 0.66666 and so on. That 6 will be repeated infinite times. So we will say that 2/3 is equal to 0.6 periodic. It means that that 6 won't have an end, and this number 0.6 periodic can be found here. There are also another kind of numbers, a little more complicated, rational numbers. Here we have the example of 11/90. If we make the division, we will find that it's equal to 0.1 finite and 2, lots of 2 to infinite 2. So 11/90 is equal to 0.1 or 0.1 infinite 2's. In the decimal part we have a finite number, which is 1, and a 2, which is infinite. So it's a little bit strange, and as you can see, rational numbers can lead us to several kinds of decimal numbers. Finite decimal numbers, like the one that we previously saw 3/4 equals to 0.75, 2/3 equal to 0.6 periodic, and 0.12 periodic. But there are other kinds of fractions, because the one that we saw, the proper fractions, are those where the numerator is less than the denominator. What about improper fractions? What are they? Well, they are the opposite. Improper fractions have the numerator greater than the denominator. For instance, 3/2. 3 is greater than 2. And what do 3/2 represent? Well, it's a fraction like it basically, you can imagine that you have a rectangle divided in two parts or halves, but you need another rectangle and you colored 3 of those halves. If you do that, you will have 1, 2, 3 halves. And also you can locate this number on the number line, and here's something really interesting is going to happen. If I start from 0 as always, and I'll go on with 1 half, 2 halves, and 3 halves, I will find something really interesting. Remember, every fraction is also a division, and if I divide 2 by 2, the answer will be 1. So 3 halves, it's a number that is after 1. And if I divide 3 by 2, remember, every fraction is also division, I will get something really interesting. But before I go on with that, I'd like to tell you that improper fractions are the only ones that can be converted into mixed numbers. To do that, we have to divide 3 by 2, but not get into the decimal result. So 3 divided by 2 is 1 and 1 more. So 3 halves is equal to 1 and a half. As you can see here, remember 3 halves is after 1. And here we can find 1 and a half. Here it is 1 and a half. That is 3 halves. And remember, we can transform this into a decimal number. A half, 1 divided by 2 is equal to 0.5, or, well, basically 3 divided by 2 is equal to 1.5, and that means that 3 halves, or 1 and a half, is equal to 1.5. And remember, I told you 3 halves is after 1, and 1.5 it's also after 1. So these are different ways of saying the same thing. 3 halves is equal to 1.5. 1 and a half is equal to 1.5. As you can see here, I have a complete rectangle colored and a half of another one colored. So it's the same but with different numbers or symbols. Let's suppose that you have another improper fraction, this time 4/3. Well, there it is represented on the number line. We count 0, 1/3, 2/3, 3/3, and 4/3. Remember, every fraction it's also division, and 3/3 is 3 divided by 3, which is equal to 1. That means that 4/3 is after 1. And well, if we want to transform 4/3 or convert 4/3 into a mixed number, the only thing we have to do is divide without getting to the decimal part. 4 divided by 3 is 1 plus another 1. So there we have it. 4/3 is equal to 1 and a third. Again, we can see that 4/3 is after 1, and we can see here that 4/3 is equal to 1 and a third. And also, if we divide 4 by 3, we will get 1.33333 infinite threes. So 4/3 is equal to 1.3 infinite 3. Again, 4/3 is after 1, and here we can see it, 1 point infinite threes. Alright, and let's have a look to a last one number. That will be 190. Alright, so if I divide 190 without getting to the decimal part, in order to get a mixed number, I will have 101 divided by 90 is equal to 1 plus 11. So 101/90 is equal to 1 and 11/90. If we go on with the division, we will find 1.12222. So 101/90 is equal to 1.1 infinite 2's. Now, there are other kinds of improper fractions, and there are some that are really interesting. For instance, what about this one? What if I get 9 first? Well, if I try to locate this on the number line, something really interesting is going to happen here. I have 0, 1 first, 2 first, and so on. Well, all of these numbers are in fact integers. Since every fraction is also a division, all of them are simply 1, 2, 3, 4, 5, 6, 7, 8, and 9. There it is, the fraction 9 first. Remember, every fraction is also a division. If I divide 9 by 1, I will get 9. That's it. So the fraction 9 first is equal to 9. This it's also called a false fraction because actually it's not a fraction, it's an integer. Now, fractions have something really interesting, something really special. You can do something like this. For instance, if I multiply both numerator and denominator by 2, I will get an equivalent fraction. That is a fraction that has the same value but with different numbers. If you divide 18 by 2, you will get once again 9. So you can convert a fraction multiplying both numerator and denominator by the same number, and you won't change it after all. You can also simplify a fraction if you will. For instance, let's suppose that I have 27 thirds and I divide both numerator and denominator by the same number in order to simplify, and I'll get 9 first. This is something really interesting that fractions have. They can be simplified or expanded without changing the real number after all. I can multiply by 2 or every number that I wish, and I will get the same answer. For instance, I will multiply by, I don't know, maybe 8. What number will I get? I will multiply by 8. 9 times 8 is 72. And 1 times 8 is 8. 72 divided by 8, once again, it's also 9. This is something really, really interesting that fractions have. Now, remember that there are other kind of numbers, and those are the negative numbers. Here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. But there are numbers on this side of the 0. Those are the negative numbers. -1, -2, -3, and so on. And they also come from fractions. For instance, -1 comes from the fraction -1 first. -2 comes from the fraction -2 first. -3 comes from the fraction -3 first. And let's have a look at this fraction, shall we? Because if I multiply both numerator and denominator by the same number, I will get an equivalent fraction. -3 multiplied by 7 will be -21, and 1 times 7 is 7. Minus 21 divided by 7 is minus 3. So as you could previously see, fractions and decimals decimals come from decimals come from fractions, and also there are negative numbers that will come from fractions. For instance, here I can find a fraction, and that will be minus 1/2. There are other fractions around there. For instance, here it could be minus 1/3, and so on. So fractions can give us a lot of numbers, a positive, negative, with decimals, with no decimals, and those are the rational numbers. At the moment you only saw positive fractions, but now we're going to work with positive and negative fractions, with which sometimes can be integer numbers, numbers without decimals, and sometimes can be numbers with decimals, and those decimals could be finite or infinite. That's all for this video. I hope you could get it. If you didn't, don't forget to text me, send me a message, whatever you want, or ask me in classes, and I'll see you in the next video. Goodbye.